Good morning, students. We will continue the lecture where we had left in our last class. There were some one or two problems remaining. So take one problem. Okay. Thank you, Norman, and same to you all. Happy Republic Day. So here is a frame. What is the specialty here is there is one inclined member and a horizontal load is also shown here. You are supposed to sketch the shear force, bending moment, and the axial force diagram for this. If you remember, earlier also I had told you the very first step in such cases is to determine the support reactions. As there is one, it is ruler, there will be one reaction. For hinge, there will be two reactions here. So in all, if you will see, externally there are three unknowns and they are non-congruent and non-parallel. So we will have three conditions of equilibrium. Suppose I assume here VA is acting up, say this VD I assume acting up, say HD I assume acting right. These are the supports I am replacing by the reactions. So that we call it the free body diagram. Now use the conditions of equilibrium for the external equilibrium of this particular structure. If I use sigma fx is equal to 0, so as to determine the external unknowns. This HA is a horizontal force acting right. This is a uniformly distributed load which is acting left. So 8 is the span and 1 kilonewton per meter is the intensity of load. So it will be equal to 1 into 8. So HA is equal to 8 kilonewton. This UDL can be converted into a single concentrated load if I am doing sigma fx is equal to 0. And I have got positive value, so it means that this assumed direction is right. Now get the value of VD. For that, for this VA and VD, do sigma Fy is equal to 0. If I do sigma Fy is equal to 0, it is VA acting up, VD is also acting up, so it is on the same side of the equation. This 10 kilonewton is acting down, so that must be on the other side. If I am doing sigma fx is 0, it means that actually I am equating the rightward forces with the leftward forces. If I am doing sigma Fy is equal to 0, it means that I am doing the upward forces equating with the downward forces. There are two unknowns in this equation, so we cannot have the two unknowns from the equation. So I will take moment, say about A is equal to 0, sigma moment about A is equal to 0. So this VA will pass from here. This HD will also pass because the supports are at the same level. So HD will also pass from the here. Right, same point A. So there will not be moment of HD and VA. There will be moment of this VD. That is anti-clockwise. Right? So it is VD and the distance between the A and D, this perpendicular distance is 2 and 2, it is a 4-meter distance. So this is VD multiplied by 4 anti-clockwise. What about the moment because of this uniformly distributed load? This is acting horizontal. So if you will see this horizontal force that will be acting in the left, so it will also produce the anti-clockwise moment. So it must be on the same side of the equation, and that will be equal to the intensity of load multiplied by the span 1 into 8. That is the total load which is acting here. And in case of uniformly distributed load, we consider that the load is acting at the center. So if it is 8 meters, so it means that it will be acting at half of the. This is the line of action of the force. Here is the perpendicular distance. This moment will be clockwise, so it has to be on the other side of the equation. So it is 10 multiplied by 2. So if you see here, VD will be equal to 20 minus 32 divided by 4. So it is nothing but minus 12 divided by 2 minus 3. So VD I have got minus 3 kilonewton. Put the value of VD here in the equation. If it is minus 3, so it is VA plus minus 3 is equal to 10. This minus will go to the other side. So VA will be equal to 13 kilonewton. So whichever positive we are getting, all those assumed directions are right. This is 13 kilonewton, this is positive, and this HD is equal to 8 kilonewton, this is also positive. So these assumed directions are correct. Right? Only we have got minus value for VD. So I will change here. This I will consider acting down, and I will consider VC is equal to 3 kilonewton. So we have got the support reactions. Considering the external equilibrium of the system, we have got the required unknowns. What will we do next after getting these support reactions? How many parts we will break it into? We will break this system into three parts. One is this vertical member. This is VA, that is equal to 13 kilonewton. There is no horizontal or a couple acting here, only a vertical force is there. B is a rigid joint. So when I am breaking the system or the element from a rigid joint, I have to show three reactions. So I will consider, say this is vertical at B, say this is horizontal at B. Suppose I am assuming this as the moment at B. I have assumed the directions randomly, vertically down, horizontal right and anti-clockwise movement. अगर मुझे पॉजिटिव आंसर आता है तो these assumed directions are right. अगर नेगेटिव आंसर आता है so it means that they must be in the opposite direction. That's all. The other member is this inclined member. Of this inclined member at joint B, whatever I had considered here, for this I have to consider opposite of that. So here I will consider VB. HB was considered right, so it has to be considered left. HB, it was considered anti-clockwise, so here I have to consider the moment clockwise, MB. There is a force acting here, 10 kilonewton. Now at joint C, it is again a rigid joint, so we have to replace it by three support reactions. Suppose I am assuming these as the reactions. Say this is VC, SC, and MC. As I have told, I am assuming the directions randomly. I don't know. अगर पॉजिटिव आता है तो assumed directions are right, और अगर negative आता है, those assumed directions are not correct, and those must be in the opposite direction. That's all. Now the vertical member here, this is the vertical member. This member is AB. This member is BC. This joint, this point is E. Now it is CD. On this CD, you will see here the vertical force is acting down. This is of 3 kilonewton. The horizontal force is acting right. This is of 8 kilonewton. There is a UDL acting here of 1 kilonewton per meter. And whatever vertical is considered here, I will consider opposite of that. So this is VC. This SC was considered left. So here SC must be considered right. This moment is considered clockwise. So here the moment is to be considered anti-clockwise. That's all. And we have separated the elements into number of parts. For our syllabus, we are having the portal frames, 3-member portal frames. So these are the 3 members, and we have separated them. Now if you will see what are the unknowns here, I will make a list of the unknowns. The unknowns are HB, VB, and MB. These are the 3 unknowns. If I see this member, these 3 unknowns are already counted. The another 3 members are HC, VC, and MC. These are the another 3 unknowns. If I come to this member, these are the 3 unknowns, but they are already considered here, and that's all finished. Here all the other forces are known. So if you will see, in all we are having 6 unknowns. And here there are 3 conditions of equilibrium. For this part, we are having 3 conditions of equilibrium. For this part of the system, we are having 3 conditions of equilibrium. So if you will see, in all we are having 9 conditions of equilibrium, and the unknowns are 6 only. So it means that out of the 9 equations, we have to use just 6 equations to get the required unknown. So we must use the equations intelligently so that we can use 6 equations and we can solve the problem easily. We can determine the required unknowns easily. I will prefer to take a vertical or horizontal members wherever possible, where the unknowns are less. If I see this member AB, if you will see here, there are only 3 unknowns. If you see in this system, there are 6 unknowns here. If you see this vertical member, again, there are only 3 unknowns. So rather than taking this vertical and inclined, I will prefer to take these 2 vertical members to solve, so that I will get the required unknowns. If I know these are already we can get them. So from the free body diagram, from the equilibrium, पहले हमने सपोर्ट रिएक्शन डिटरमाइन किया फ्रॉम द एक्सटर्नल इक्विलिब्रियम ऑफ द सिस्टम. द सिस्टम वाज इन स्टैटिक इक्विलिब्रियम. So from the equilibrium of member AB, what you will have here, do sigma fx is equal to 0. So if you will see, this 13 is the vertical, this VB is vertical, this is a couple. So HB is the only horizontal force acting, that is acting right, and there is no other force acting in the system, horizontal or inclined. So that HB must be equal to 0. Now do sigma Fy is equal to 0. So it means that I am equating the upward forces with the downward forces. This 13 is acting up. This is a couple, this is a horizontal force, so these two will not be there in the equation. This VB is acting down. Upward forces I have to equate with the downward forces, so it is equal to VB. So I have got the another unknown. This is positive, so this assumed direction is also correct. Now do sigma moment is equal to 0. Say I am taking moment about B is equal to 0. There is no moment of all these forces, only MB will be there because this is a free vector. We need not to worry about distance for that. HB and VB are passing from here, so there is no moment of that. This 13 kilonewton will also pass from here, so there will not be any moment of that. So there is as such no force which will produce any moment. So this MB is equal to 0. So we have got 3 of the unknowns out of the required 6 unknowns. HB I have got 0, VB I have got 13, and this MB I have got 0. Now, rather than solving this inclined member, इसका यह मतलब नहीं कि हम inclined member solve नहीं कर सकते. We can solve, but that will be lengthy and a little tedious. More calculations may be involved there. That's why we normally prefer wherever possible the vertical or the horizontal members. So here we will take this another member as CD, and CD member we will solve from the equilibrium of member CD. If you do sigma fx is equal to 0, so what it will be from sigma fx is equal to 0, this 3 will not be there in the equation. This 8 will be there, it is acting right. Now this UDL which is acting left, so that has to be on the other side of the equation. 1 kilonewton is the intensity and the span is 8. The rightward forces I am equating with the leftward forces. This AC is considered acting right, so it must be on the same side as the 8 kilonewton. So this 8 will get balanced by this, and we will get the value of AC is equal to 0. Now do sigma Fy is equal to 0. If we do sigma Fy is equal to 0, the upward forces we will be equating with the downward forces. This 3 is acting down. This is a horizontal force, it will not be there in the equation. This is a horizontal force, AC, it will not be there in the equation. This MC will also be not be there. And this VC, it is also acting down. So the AC and these 3 must be on the same side of equation. Plus VC must be equal to 0. So it means that VC is equal to minus 3. After getting this, do sigma moment is equal to 0. About any point in the plane, we try to take the moment where the more number of forces or the unknowns are passing. Say I am taking moment about C is equal to 0. If we do sigma moment about C is equal to 0, there will not be any moment of these two forces. This MC is a free vector, and this MC will be there in the equation. This is MC, it is anti-clockwise. Because of C, this 3 kilonewton again it will be passing from here, so there is no moment. This 8 kilonewton, this is the force, I am taking moment here, so it will also produce the anti-clockwise moment, so it must be on the same side of the equation. 8 multiplied by this perpendicular distance is also 8. Must be equal to, because this is the UDL, it is acting in the direction left, so this is where it can be assumed as concentrated. So the moment developed because of this will be 1 into 8 is the intensity of load, 1 into the intensity of load 8, so that is total concentrated load, and it is assumed as acting at the center. So the entire span is 8, so half of that will be 4. So MC, if you will see, will be equal to 32 minus 64. So it means that it is equal to minus 32 kilonewton meter. So MC we have got minus, it means that this assumed direction is also not right. It means the opposite. Okay, no problem. It is minus 32, VC is equal to minus 3, and SC is equal to 0. Finish. So we have done with almost 50% of the solution, or the 60% of the solution. We have got the required unknowns. After getting required unknowns, if there is any minus, so we have to sketch the correct diagrams with the correct values, correct directions. So what I will do, say for this vertical first I will sketch. This is the vertical member. This is 13 kilonewton. HB I have got 0, so I need not to sketch that. VB 13, it was assumed down and I have got positive value. So this is correct. 13. Fourth diagram for member AB. It is A and this is B. Now next for the inclined member. What about for this inclined member? Say here is the inclined member. For this inclined member, HB is 0, so that I did not to sketch. VB, I had got positive value, it was considered up. So this is positive here. It is 13. MB assumed up and I have got minus value. It means that it is not acting up, but this must be acting down. HC, I have got 0, so I need not to sketch that. MC, I had assumed clockwise, I have got minus value. It means that it must be anti-clockwise. And this is equal to 32 kilonewton meter. So I have sketched the free body diagram of second part also. What to do next? Next sketch the free body diagram of the third member. It is a 3-member portal frame. Once you know the free body diagrams, then we can get the shear force and bending moment diagrams. ये UDL है. How much was the reaction here? This was down, तो ये रहेगा up, ये रहेगा down. This is 3. This is 3. No horizontal. This is 1 kilonewton per meter. और यहाँ पर clockwise है, anti clockwise, तो यहाँ पर ये हो जाएगा clockwise. And this is 8 kilonewton. Is it right? This is 32 kilonewton meter. That's all. So these are the free body diagrams. AB, it is BC, and this is CD. This point is E, where the force is acting. Now sketch the shear force and bending moment diagram. What about for this member AB? If you will see for this member AB, these are the axial forces only and they are compressive in nature. So sketch this, and here you sketch the axial force diagram. This is AFD and this is compressive. The magnitude here is 13. There is no force here and the 13 acting in the opposite direction, so that will go back to 0. So this is the axial force diagram. Now if you solve this member, if you remember earlier also we have solved the inclined member. जब मुझे inclined member solve करना रहता है, so in that case I have to resolve all the forces along and perpendicular. So here the complication will be there. See, here is the member. This is the 13 kilonewton force. I have to resolve this force along and perpendicular. Right? जहां पर भी कोई इंक्लाइन मेंबर आता है तो मुझे वहां पर रिजॉल्व करना पड़ेगा फोर्सेस अलोंग एंड परपेंडिकुलर. हाउ मच दिस एंगल विद द हॉरिजॉन्टल विल बी? अगर ये देखते हैं पोर्टल फ्रेम ऐसे था, दिस वाज 5 मीटर, दिस वाज 8 मीटर. It means that if I drop a perpendicular here, this height must be equal to 3 meter and this base was given as equal to 4 meter. So this angle will be 36.87 degrees. That is angle made by this member with the horizontal. It is 36.87 degrees. If it is 36.87, it will be 90 minus that. So again this angle will be 36.87. If these are the angles here, then how will you get the components? This is 13. If you resolve it here, it will be acting vertically up. 13 cos of 36.87. Because of this, if I want to resolve here, this is how the force will be acting, and it will be 13 sin of 36.87. So this is how that force can be resolved. Similarly now, for the other force, the force which is acting here at the center, this is the 10 kilonewton force. How will you resolve? This is where you have to resolve this and this. What is the angle made by this force with the normal? See, this is 36.87. So here also the angle with the horizontal is 36.87. So this angle must be equal to 90 minus that, and this angle will be equal to 36.87 degrees. हमको थोड़ा सा ज्योमेट्री इन्वॉल्व रहेगा. Angle with the horizontal is 36.87. If I draw a line parallel to this, these are the corresponding angles. So this must also be equal to 36.87. This is vertical, this is horizontal. If it is 36.87, so this must be 90 minus 36.87. And this is normal and this is along. If it is 90 minus 36.87, so this angle must be 36.87. This force is 10. So if I resolve it, this will be 10 cos of 36.87, and this component will be 10 sin of 36.87. Now come to this member here. This is the force 3 kilonewton. This is this force. Again, it is to be resolved along and perpendicular. Whatever the angle made by this force, the angle made by this force will also be same. So this is 36.87 degree here. This force is 3. So this component will be 3 cos of 36.87, and this component here will be 3 sin of 36.87. Now please solve and give me the answers. हमने ये मेंबर सॉल्व कर लिया है. नाउ वी आर सॉल्विंग दिस अनदर और इंक्लाइन मेंबर. क्या किया था, पहले हमने एक्सटर्नल सपोर्ट रिएक्शन डिटरमाइन किया है, फिर जो भी निगेटिव आंसर्स आए अगर कोई आते हैं तो उनको हमने पॉजिटिव करके करेक्ट डायरेक्शन में स्केच किया. We had sketched the free body diagram of the entire system. Then we have split the system into number of components, whatever are the number of members, और जहां जहां पर भी rigid joint थे, those rigid joints we have replaced by suitable 3 reactions. क्योंकि अगर rigid joint रहता है तो 3 reaction आना चाहिए, vertical, horizontal and rotation. So we had replaced by them. उसके बाद क्या किया, हमने आइडेंटिफाई किया कि how many are the unknowns, and accordingly we have used the members intelligently. Required number of equations we have used, and we have determined the required number of unknowns whatever were there. फिर उसके बाद किया जहां जहां पर भी नेगेटिव वैल्यूज आए थे हमने उसको पॉजिटिव वैल्यू करके वो डायरेक्शंस को करेक्ट कर दिया. देन वी हैव स्केच्ड द सेपरेट फ्री बॉडी डायग्राम फॉर ईच. अगर कहीं पर कोई इंक्लाइंड फोर्स रहता है तो वी हैव टू रिजॉल्व दोज इंक्लाइंड फोर्सेस along and perpendicular to the member, so that the force which is acting along, that we call as the axial force, the force which acts perpendicular to the member, that we call as the shear force. So because here we are supposed to sketch the shear force and the axial forces, so we resolve the members along and perpendicular, along the member and perpendicular to the member for this case. So now how much will be the forces here? How much this will be? 13 cos of 36.87. ये कितना रहेगा? 13 sin of 36.87. Sin of means it will be 3 by 5, 39 by 5. So that is nothing but 7.8. So this will be 7.8. It will be 13 multiplied by 4 by 5. So that is nothing but 52. So that is 10.4. So this force here will be 10.4. Is that right? Please keep confirming the answers. Here the force will be 10 cos of 36.87 is equal to 4 by 5, and sin of 36.87 is equal to 3 by 5. ये हमको पता है. So I am using this 10 cos of 36.87. Cos is 4 by 5. So it will be 10 multiplied by 4 divided by 5. So that is nothing but 40 divided by 5 is 8. So this answer is 8. So this answer must be 6 here. Now for this, it is acting down. This is acting left. How will you do it now for this member? 3 cos of. So that must be 3 multiplied by 4 by 5. So that is equal to 12 by 5. 12 by 5 is nothing but 2.4. So this must be 2.4. It is 3 sin off. So it must be 3 multiplied by 3 by 5. So that is nothing but 9 divided by 5. So that is nothing but 1.8. Okay, fine. I have got all the required values. I have got all the required values. राइट, क्या किया था हमने? पहले सपोर्ट रिएक्शन डिटरमाइन किया, कोई आंसर अगर निगेटिव आता है तो उसको करेक्ट करके सही डायरेक्शन लिखा, फिर एलिमेंट को नंबर ऑफ कंपोनेंट्स में ब्रेक किया, जहां पर भी कोई रिजिड जॉइंट था वहां पर हमने 3 रिएक्शन लिए, वर्टिकल, हॉरिजॉन्टल एंड रोटेशन। फिर हमने आइडेंटिफाई किया कि अननोन्स कितने हैं, कौन से मेंबर यूज करना चाहिए, कौन से इक्वेशन यूज करना चाहिए, कहां शेयर हॉरिजॉन्टल, वर्टिकल एंड मोमेंट लेना चाहिए। देन अकॉर्डिंगली वी हैव गॉट द रिक्वायर्ड अननोन। जो भी निगेटिव आया था फिर हमने उसको करेक्ट यहाँ पर डायरेक्शन किया एंड वी हैव रिटन विद द पॉजिटिव साइंस। फिर उसके बाद हमने हर मेंबर को सेपरेटली सॉल्व करना शुरू किया सो एज टू गेट द एक्सियल फोर्स, शियर फोर्स एंड बेंडिंग मोमेंट डायग्राम। अगर कहीं पर कोई इंक्लाइन मेंबर आता है, कहीं पर कोई फोर्स इज नॉट एक्टिंग अलोंग एंड परपेंडिकुलर टू द मेंबर, सो दोस फोर्सेस वी नीड टू रिजॉल्व। जैसे ये 13 किलोन्यूटन था, this is the member, this is the axis of the member, so we need to resolve this force along and perpendicular. Similarly, this force we need to resolve along and perpendicular, this is the force we need to resolve it along and perpendicular. So we have resolved all the forces along and perpendicular because the inclination was known. So after determining this is what we have got finally. After knowing this, for member we can sketch the shear force and bending moment diagram for this member very easily. How will you sketch the axial force diagram? See, say this is the axis of this member. It is 7.8 compression. So this is 7.8. यहाँ से यहाँ तक आने तक कोई फोर्स नहीं है. So there is no force acting here. फिर उसके बाद यहाँ से देखिए 6 अपोजिट डायरेक्शन में है. So it will come 6 down. 7.8 में से 6 माइनस करेंगे. So the remaining will be only 1.8. Because this 6 का ड्रॉप रहेगा. फिर उसके बाद यहाँ से यहाँ तक कोई फोर्स नहीं है, so there is no force here. Then it is 1.8 in the opposite direction, so it will come down and it will come to 0. So this is the axial force diagram for the member BC and this was E. Is it right? How to sketch the shear force diagram? This is 10.4 acting up. So यहाँ से यहाँ तक there is no force acting. Then it is 8 down, so 8 नीचे आ गया, तो इसका मतलब the remaining will be only 10.4 में से 8 माइनस किया, so the remaining is 2.4. Then there is no force acting from E to C, then it is 2.4 down, so it will come to 0. This is the shear force diagram. What about the bending moment diagram? Say for this is nothing but member joint B, this is C, and say this is the point E. For bending moment at B is 0. The bending moment at E, it will be 10.4 multiplied by how much this distance will be? See, अगर हम ये देखते हैं, so this distance was 4, this was 3, so this inclined distance is 5, and as this is the midpoint, it is 2 and 2, so it means that from the concept of symmetry of triangle, whatever this distance will be, it will be shared equally. So this total distance is C, as is the midpoint, so it must be 2.5 meter, and this must also be equal to 2.5 meter from the simple geometry. हमको थोड़ी सी geometry आना चाहिए. So the bending moment at E, it will be 10.4 multiplied by 2.5. So if you want to have a moment at E, bending moment at E, that will be equal to 10.4 multiplied by 2.5. How much it will be 10.4 multiplied by 2.5? कितना रहेगा? 25 चौक 100 का 0, कैरी 10, 10 का 0, कैरी 1, 25 एक 25 और एक 26. Decimal 2 के बाद. So this is 26 and the variation must be linear. This is 26 kilonewton meter. Is it right? अच्छा, यहाँ पर एक कपल भी था. How much that couple was? 32. वो हमने यहाँ पर लिखा नहीं है. It is 32 kilonewton meter. So now what about the bending moment? Just at bending moment, just at left of, क्योंकि जहां पर भी कपल आता है तो वहां पर at and just left या just right करना पड़ेगा. just left of B. This is positive क्योंकि देखिए हम यहाँ पर है, यहाँ ऑब्जर्वर है, this is the force acting and we are determining moment here because of this. So this moment अगर सेक्शन की ये साइड में मूवमेंट अगर क्लॉकवाइज रहता है तो that we call as the positive bending moment. So this 10.4 will produce the positive bending moment. This is up to E. This is joint E of the member. This is B. This is the point E. Now what about bending moment just at the left of C? यहाँ पर चाहिए मुझे just at the left of C. How much that bending moment will be? Because of this 10.4, it will be 10.4 and this total distance will be 5. It is positive. Then because of this, there will not be any moment of this 7.8. There will not be any moment of this 6. Right? There will be moment because of this 8 and it will be in the opposite direction. 8 multiplied by the यहाँ से यहाँ तक का distance रहेगा 2.5. So it is 10.5 into 5 will be nothing but 52 minus 20. So it is equal to 32 kilonewton meter and it is positive. So this is now the bending moment will increase here. यहाँ तक 26 था, यहाँ पर 32 रहेगा. This is also positive. So this is sagging. And next is the bending moment at C. It will be ये सब जो total रहेगा. It is अगर मैं यहाँ पर लेता हूँ. Now I need to consider this couple also. See, this is the section now. This is the couple acting. So it will be anti-clockwise now. So it is in the negative. So it will be 52 minus 20 minus 32. So the net bending moment must be 0. So it will come to 0. This is the bending moment diagram and this entire is positive. So this is sagging bending moment. This is positive shear force and this is compression. एक्सियल फोर्स डायग्राम में हमको कॉम्प्रेशन है या टेंशन है लिखना पड़ता है. शेयर फोर्स डायग्राम पॉजिटिव है या नेगेटिव लिखेंगे. बेंडिंग मोमेंट डायग्राम भी पॉजिटिव है या नेगेटिव लिखेंगे. पॉजिटिव इंडिकेट्स दैट इट इज sagging. Okay, fine. So here this is how we can get the axial force, shear force and bending moment diagram for the second member. Is it okay? Now what will you do? Now we need to sketch the shear force and bending moment diagram for the next member, right? After the lecture, you please refer the video again, make the notes of your own, try to solve the things your own. If you get any difficulty, please ask them, don't hesitate. Now for this member CD, all the forces are known. First for, see यहाँ पर है observer, here is the observer. पहले axial force के लिए, so this 3 kilonewton is the force which is acting along the axis of the member and it is tensile in nature. So I will write here 3 and then it is 3 down, right? So this is 3, यहाँ से यहाँ तक कोई axial force नहीं है, फिर this is 3 down. So this is 3 and 3 and here I will write tension. This is axial force diagram. What about for the shear force diagram? See, from here, if you will see, there is no force acting here perpendicular to this member. A force which is perpendicular to the member is the shear force diagram. There will not be any contribution of this couple in the shear force. There will not be any contribution of this in the shear force. The shear force will be here because of this UDL which is acting horizontal. So यहाँ से यहाँ तक UDL है and in between there is no other force acting. When the uniformly distributed load is acting, the shear force variation will be linear and it is acting left, so it is acting left. Right? It is negative. क्योंकि अगर यहाँ कुछ रहता तो that will be positive because of this UDL will be negative. But there is no horizontal force acting here, so there is no positive shear force. यहाँ पर shear force 0 है और जैसे जैसे हम नीचे आ रहे हैं, the force is increasing in the left direction, so that is negative shear force. It is 1 and it is 1 kilonewton per meter and the height is 8. So at this end, just before this, just before the support D, it will be 1 into 8. The shear force will be 8 kilonewton. और ये यहाँ पर फिर जैसे ही हम डी पर आ जाएंगे, दिस 8 kilonewton is back and it will come to 0. So this is nothing but the shear force diagram and this is minus. Right? Then how to sketch the bending moment diagram? देखिए यहाँ पर अगर हम देखते हैं तो बेंडिंग मोमेंट इज 0 जस्ट एट द जॉइंट, बट इफ यू विल सी दिस कपल, this is how the moment is acting here. So this moment is acting positive, right? So the bending moment here will be 32 kilonewton meter. जैसे जैसे हम नीचे आएंगे, the bending moment will keep on reducing. There is no moment here, so the bending moment here must be 0. And as it is because of the uniformly distributed load, so the bending variation must be parabola. How you can have, if you will see the bending moment at any distance x, what you will have here, you see the equation. Bending moment at any distance x is equal to this 32, right? This is acting this way and this load will be acting in the opposite direction. So it is minus 1 into, let the distance was considered as x, and 1 into x is nothing but the total load. 1 is the intensity of load, x is the span, so the total load acting here is 1 into x, and that will be acting at half the height, so it is x by 2. So you will find here that the bending moment at any distance x is equal to 32 minus x square by 2. And this equation is true. From here it was considered as x, so at this end x is equal to 0, at this end x is equal to 8. So this equation is true for x is greater than or equal to 0, less than or equal to 8 meter. And here you will find that the bending moment variation is parabolic. That's why the diagram will be a parabola. So this is how the bending moment diagram will be for the member CD. And this is again sagging bending moment. This is BMD. Right? तो बहुत ज्यादा मुश्किल नहीं है. आई होप दैट यू आर अंडरस्टैंडिंग दिस कंसेप्ट. ये समझ में आ रहा है कि विल समवन प्लीज आंसर इन द चैट बॉक्स. प्लीज आंसर इन द चैट बॉक्स एंड प्लीज टेल मी, आर यू एबल टू अंडरस्टैंड दिस व्हाट आई एम एक्सप्लेनिंग हियर? प्लीज रिप्लाई इन द चैट बॉक्स. ये तुम लोग को समझ में आ रहा है कि मैं क्या बता रहा हूं? हाउ टू स्केच. ओके, थैंक यू शेरदुद्दीन. तो उनको पोर्टल फ्रेम है, बीम्स का भी रहेगा, लेकिन आई एक्सपेक्ट दैट इन एग्जामिनेशन आल्सो बीम पर कम पूछेगा और पोर्टल फ्रेम पर ज्यादा पूछना चाहिए. Now the last problem of this particular topic, and then we will start the another topic. The last problem here is okay. Now again it is a portal frame. It is a 3-member portal frame. AB is one member, BC is another member, and CD is one more member. Height of this member is 5 meter. For this inclined member, the horizontal projection is 4 and the vertical is 3. It means that again this height or the length of the member will be 5. Here also it is 4 and it is 3. So length of this member CD will again be equal to, from the Pythagoras, 3, 4, so it must be 5. It is hinge, it is ruler. There will be 2 unknowns here, there will be 1 unknown here. So externally, if you will see, there are only 3 unknowns and they are non-congruent and non-parallel. So it means that it is the externally statically determinate structure. It is 32 kilonewton meter. It is a uniformly distributed load which is not directly acting at BC. It is acting vertical. It is not acting perpendicular to this BC. It is acting vertical. जैसे हमारा जो पिछला प्रॉब्लम था जो हमने सॉल्व किया, तो उसमें भी यहाँ पर एक फोर्स ऐसे एक्ट हो रहा था. This was acting perpendicular to this member. So here also, if you will see this 24 multiplied by this span, because this force is shown right vertically acting down, so it is acting on 4 meter span. So it means that actually it is a 88 kilonewton load which is acting down. 22 multiplied by 4. So here जैसे लोड पहले था अभी भी वही कंडीशन है. The force is acting inclined to the member. It is not acting perpendicular to the member. When the force is acting perpendicular to the member, it is much simple. When the force is acting inclined, तो हमको थोड़ा सा काम करना पड़ता है. First, we will determine the external support reactions. Let us assume this is VA, say this is HA, say this is VD. This hinge I am replacing by these two reactions. This ruler I am replacing by a vertical reaction, because whatever is the direction of rolling, the reaction will be perpendicular to that. So HA, VA and VD are the three unknowns. From the external equilibrium of this system, use for sigma Fx is equal to 0. So HA is the horizontal force. There is no other horizontal or inclined force acting, so HA will be 0. Next, you do sigma Fy is equal to 0. VA is acting up, VD is also acting up. So it is VA plus VD. These are the two forces which are acting up. And because of this 22 kilonewton per meter, it is the distributed load. So that will be acting down. So it must be acting on the other side of this. So it will be 22 is the intensity and the span. Because this force is acting vertically down. So it is acting on a span of 4 meter. So that is this AD. So it is VA plus VD is equal to 88. This is the equation. Next, you do sigma moment is equal to 0. I prefer to take moment about 0.0. So more forces are passing from here. There will not be any moment of these two. Moment will be there because of this VD and this 22. This VD, the moment will be anti-clockwise. So that is VD multiplied by 4 and 4. This is the line of action of force. Here is the perpendicular distance. So the total distance is 8. Now because of this UDL, as this is the UDL which is acting here, so this is the line of action of force and it will produce clockwise movement. So that I am sketching on the other side of the equation. It is 22 multiplied by 4 is the intensity of load multiplied by the span. So that is that concentrated load, and since the span is 4 meters, so that will act at half of that. So it will be acting at a 2 meter distance. So multiplied by 2. So 88, 4 and 4 will get cancelled. So it means that VD will be equal to 22. If VD is equal to 22 kilonewton, put this value here and you will get VA is equal to 66. And all our directions are positive. It means that all our assumed directions are right. This VA is equal to 66. This VD is equal to 22. And that HA I have got 0. So I need not to sketch this force. Finish. So here we have got the required external unknowns. Is it okay? Is it okay? So this is how we can get the required external unknowns. After getting the reactions, after getting the unknowns for the supports, after solving the problem for the external equilibrium, now you break the element into number of components. How this can be broken into number of components? First, a vertical component. Second is this inclined component. And third is this inclined component. Is it right? We are breaking these into the components. This VA is 66. There is no horizontal and there is no couple here. As I am breaking the system from this joint, it is a hinge joint. So I have to show three unknowns here. Say I am sketching VB. Suppose I am sketching HB. Say I am considering a moment MB. Whatever we have considered here, for this member we have to consider opposite of that. HB is considered right because randomly I have assumed these directions. Positive आता है तो ठीक है, अगर negative आएगा तो we will change at the end. HB is considered right, so here it must be left. This VB is considered down, so VB must be up. This MB is considered anti-clockwise, so here I have to consider MB clockwise. Because when I will join the two members, the net must be 0. Now what to do with this UDL? How much is this UDL? See, this is the UDL which is acting on this member, and how much that will be equal to? That will be equal to total load will be equal to 88 kilonewton. Is it right? The span is 88. How that force we have to show here? Because this is in form of uniformly distributed load. I have to show uniformly distributed load here. सपोर्ट रिएक्शन के लिए हम उसको टेम्पररीली कॉन्सेंट्रेटेड लोड में कन्वर्ट करते हैं, लेकिन जब मुझे शेयर फोर्स और बेंडिंग मोमेंट डायग्राम स्केच करना है, कॉन्सेंट्रेटेड लोड का शेयर फोर्स का बिहेवियर अलग आता है, कॉन्सेंट्रेटेड लोड का बेंडिंग मोमेंट का बिहेवियर अलग आता है, और यूनिफॉर्मली डिस्ट्रीब्यूटेड का शेयर फोर्स का और बेंडिंग मोमेंट का बिहेवियर उससे अलग आता है. So it is not a concentrated load, but this is a distributed load. How to replace this distributed force here? क्या करेंगे पहले देखिए. This is very important concept. This 22 you multiply by the span on which it is acting. It is vertically down, so multiplied by 4. So it means that the total load acting here is 88. But it is not a concentrated load. अगर मुझे सपोर्ट रिएक्शन डिटरमाइन करना है तो हम उसको कॉन्सेंट्रेटेड लोड में कन्वर्ट करके मूवमेंट वगैरह ले लेते हैं. इट इज ऑल राइट. लेकिन जब मुझे शेयर फोर्स और बेंडिंग मोमेंट डायग्राम स्केच करना है तो कॉन्सेंट्रेटेड लोड का बिहेवियर अलग आता है और डिस्ट्रीब्यूटेड लोड का बिहेवियर अलग आता है. सो हाउ टू रिप्लेस दिस डिस्ट्रीब्यूटेड लोड बाय इक्विवेलेंट डिस्ट्रीब्यूटेड लोड हियर? तो दैट आई एम एक्सप्लेनिंग. अगर ऐसे कोई इंक्लाइन मेंबर है जिस पर ऐसे कोई हॉरिजॉन्टल अगर यूडीएल वगैरह बताता है, so first you convert it into concentrated load, resolve it along and perpendicular, right? How will you resolve this? See how much this angle will be. This is 3, this is 4. So again the angle must be 36.87 degrees. So angle with the horizontal here must be 36.87. So अगर मैंने इसको यहाँ पर मार्क किया, इसका horizontal line parallel to this, so these will be the corresponding angles. ये 36.87, तो ये भी 36. तो 90 minus 36.87, so this will become 36.87. So how much this force will be? 88 cos of 36.87. How much this here will be equal to? 88 sin of 36.87. And just explaining you, अगर कोई यूडीएल रहता है, एक्चुअली यूडीएल यहाँ पर ऐसे एक्ट हो रहा है. How we can replace that UDL by the equivalent UDL that I am explaining you? Because this is in form of UDL. How much this will be? 88, and cos of 36.87 is nothing but 4 by 5. So that 4 by 5 is nothing but 0.8. So 8 is a 64 ka 4 carried 6. 8 is a 64 and 6 is 60. So this must be 60.4. So it means that this force must be 60.4. 4 by 5.8. It is 8 and carried 4. 8 8 64 का 4 carried 6. 8 8 64. 64 अच्छा 70 रहेगा. So it must be 70.4. Is it okay? 70.4. Please keep supporting the answers. What about this component here? This component here will be 88 sin of 36.87. Sin of 36.87 will be 3 by 5. So that is nothing but 0.6. So 8 से 48 के 8 carried 4 और 8 से 48 49 50 51 52 52. So this is 52.8. So this is equal to 52.8. ओके, लेकिन ये जो लोड है यहाँ जो मैंने बताया है ऐसे कॉन्सेंट्रेटेड लोड, यहाँ पर तो कोई कॉन्सेंट्रेटेड लोड नहीं था. अगर कोई कॉन्सेंट्रेटेड लोड रहता तो दिस इज ऑल इनफ, बट दिस इज नॉट अ कॉन्सेंट्रेटेड लोड, इट इज यूनिफॉर्मली डिस्ट्रीब्यूटेड लोड. So this load again I have to replace by the distributed load. So that is how it will be. Now it will be acting perpendicular to that member. So how much it will be? This is the concentrated load, and how much span it is acting at? If it is 4, it is 3. So this distance must be equal to 5. So divide it by 5 back so that I will get this distributed load. This is nothing but 14.08. So this is the intensity of load, 14.08 kilonewton per meter. और ये जो 52.5 आया है, that is because of this component is because of this. ये जो 88 आया था, that was because of the UDL, uniformly distributed load. इट मीन्स दैट ये जो 52.8 है ये भी यहाँ से यहाँ तक टोटल डिस्ट्रीब्यूट होना चाहिए और दिस इज एक्टिंग डाउन सो दैट आई विल स्केच दिस वे it is uniformly distributed load which is acting along the member 52.8 and this is acting on a span of 5 meters so it is 52.8 divided by 5 so that must be 10.56 so this is 10.56 kilonewton per meter this is 52.8 divided by the span is 5 so I have got 10.56 so it means that there is a UDL here which is acting perpendicular to this member and it is of intensity 14.08 kilonewton per meter. And there is a axial force here acting throughout down and it is of intensity 10.56 kilonewton per meter. राइट तो इस तरह से अगर कोई यूनिफॉर्मली डिस्ट्रीब्यूटेड लोड इंक्लाइन मेंबर पर एक्ट होता है तो पहले सपोर्ट रिएक्शन डिटरमाइन करने के लिए उसको भी कंसीडर ए कंसंट्रेटेड लोड में डिटरमाइन द सपोर्ट रिएक्शन बट व्हेन वी स्केच द फ्री बॉडी डायग्राम ऑफ दैट इंक्लाइन मेंबर तो ये लोड को परपेंडिकुलर टू द मेंबर एंड अलोंग द मेंबर रिजॉल्व करना पड़ेगा दिस इज डिस्ट्रीब्यूटेड सो दोस कंपोनेंट्स विल आल्सो बी डिस्ट्रीब्यूटेड यूनिफॉर्मली हाउ टू गेट दैट First, convert that concentrated load. This is 22 kilonewton per meter. It is acting on 4 meter, so the total load is 88. This 88 you resolve along and perpendicular, so that you will get this 88 cos of this and 88 sin of this. That will be 70.4 and it is 552.2. But this is not the concentrated load. यहाँ पर तो कोई distributed load था. अगर concentrated 88 kilonewton रहता तो यहाँ पर enough था. जैसे हमने पीछे problem नहीं किया. But here it is a distributed load. So this load again we have to convert into distributed. So this is acting on a span of 5 meter. This load 52.5 will be again acting on the 5 meter span. So this divided by 5 and this divided by 5 I will get this intensity of load perpendicular to the member and along the member. That is this. Now this joint C you resolve here a vertical, a horizontal and a couple. This is vertical at C, horizontal at C. Say this is moment at C. Now whatever I have considered here, I will consider in the opposite direction BC, HC, and it was clockwise, so here it must be anti-clockwise MC. Now this VD is vertical here, and that is equal to 22 kilonewton. That's all finished. This is how the diagrams are sketched. What are the unknowns? There are 3 unknowns for this member. यहाँ देखते हैं तो 6 unknown, यहाँ देखते हैं तो 3 unknown. But if you will see, in all there are not 9, there are just 6 unknowns. What are the 6 unknowns? HB, VB, MB, HC, VC, MC. These are the only 6 unknowns. मैंने पहले बोला है हमने इंटेलिजेंटली वी हैव टू सेलेक्ट द मेंबर्स व्हिच इज सिंपल फॉर अस टू सॉल्व अगर मैं यहाँ देखता हूँ तो 3 मेंबर है ये हम इजीली सॉल्व कर सकते हैं अगर यहाँ देखता है तो देयर आर 6 नंबर ऑफ अननोन्स इट विल बी डिफिकल्ट टू सॉल्व अगर ये सॉल्व करने के बाद 3 मिल गया दो 3 वी विल पुट हियर एंड वी कैन गेट द रिक्वायर्ड दिस 3 अननोन बट देयर आर टू मेनी फोर्सेस व्हिच आर एक्टिंग हियर इन द सिस्टम दैट मे ऐड अप टू द कॉम्प्लिकेशन टू द प्रॉब्लम अगर मैं ये पहले वर्टिकल मेंबर सॉल्व करता हूँ then this inclined member यहाँ पर 3 unknown है easily we can do ये inclined member में भी यहाँ पर 3 unknown है it is easy here there are too many forces there are more number of unknowns which are appearing here so it may be a complicated member to solve first I will solve member AB so from the free body diagram of AB for the equilibrium of member AB what you will have do sigma fx is equal to 0 if you will do this is the force which is vertical it will not be there this is vertical this is coupled so this will not be there only hb will be there in the equation and hb is equal to 0 we have got one unknown now do sigma fi is equal to 0 this is acting up 66 this is a couple it will not be there this is horizontal it will not be there this vp is acting in the opposite direction so must be in the other side upward forces with the downward forces so I have got positive value so this is correct now sigma moment is equal to 0 We can take moment about any point. Say I am taking moment about B because more number of forces are passing. There is no moment of this HB and BB. This couple is a free vector. This MB will be there. It is anti-clockwise MB. There will not be any moment of this because this is again passing from the B. So there is no other force which the couple is there that is to be accounted. So this MB is equal to 0. I have got the three required unknowns HB, MB, and VB. HB is 0, VB I have got positive value 66, MB I have got 0 value. Finish. ये हमको तीन मिल गया है तो we can come here. We are having these three unknowns. Then we can determine the other three unknowns. But if you try to determine these three unknowns, there are too many forces which are appearing to be acting in the system that will make the system complicated, that will make the system complex to solve. So I prefer to solve this part. What were the dimensions? The horizontal distance was 4, and this vertical distance was 3 meters. Now see it from equilibrium of member CD. What you will do if you do sigma fx is equal to 0, it will be HC which is acting right. There is no other horizontal or inclined force acting in the system, so HC is equal to 0. Do sigma Fy is equal to 0. If you do sigma Fy is equal to 0, this VC is acting down. This SC and MC will not be there. This 22 is acting up. So the downward forces are equal to upward forces, or the upward are equal to downward. It is the same thing. I have got the value of VC. Next, you do sigma moment is equal to 0. So I am taking moment about this point C. So this SC and VC will be passing from here. There is no moment of those two. This MC will have the moment. It is anti-clockwise. And see, this 22 kilonewton is also passing from here. It will also produce the anti-clockwise moment. So this MC and that moment because of this 22 will be on the same side of the equation. It is 22 multiplied by this horizontal is 4 is equal to 0. It means that MC is equal to minus 88 kilonewton meter. It means that this assumed direction is not right. That must be in the opposite. So first here, as we were knowing these 6 unknowns, so we have determined all the required unknowns. SC is equal to 0, BC we have got is equal to 22, and MC we have got is equal to minus 88. Finish. We have got the required unknowns. After getting these required unknowns, one more time I will sketch the diagram by replacing the forces here. It is 66. What about this HB? 0, need not to sketch VB. I have got positive, so it is acting down. This MB, I had assumed anti-clockwise. MB is 0, so I need not to sketch. And this is 66. This is the free body diagram for AB. I have got one free body diagram. What about the next free body diagram here? That is because of this inclined member. That is this. What is VB? VB is 66. It is okay. How much is HB? HB is 0, so I need not to sketch. What about this MB? MB is also 0, so I need not to sketch. The other forces will be this uniformly distributed load which will be acting perpendicular to this, and this is uniform axial force acting. This is 14.08. It is not acting vertically down, now it is acting perpendicular to the member. 14.08 kilonewton per meter, and this is 10.56 kilonewton per meter. What about VC? VC I have got positive and it is 22, so this is right. HC it is 0, so I need not to sketch this. MC I had assumed clockwise and it is minus, so it means that actually it must be acting anti-clockwise. And the magnitude is 88 kilonewton meter. Magnitude is okay. This minus only indicates मैंने जो direction assume किया था वो सही नहीं है. That must be in the opposite. Okay. So I have sketched the free body diagram of second member also. What to do next now? Sketch the free body diagram of the third part. The third member, that is this. यहाँ पर 22 है. This is member AB. This is member BC. Now this is member CD. VC I had assumed down. I have got positive value, so it must be acting down. Add assume SC, right? I have got SC 0, so I need not to sketch that. Add assume MC anti-clockwise, and I have got this value negative, so it means that it is not anti-clockwise, it must be clockwise. 88 kilonewton meter. Finish. I have got all the free body diagrams. Now I can sketch the axial force diagram, the shear force diagram, and the bending moment diagram. How will you get this? Here, these are the forces which are acting along the axis of the member. So it will have only the axial force diagram. There is no force which is acting perpendicular. There is no force which will produce any moment in the system. So here we will have only the axial force diagram AFD. It is 66 up. फिर यहाँ से यहाँ तक कुछ नहीं है. It is straight, and then this 66 down, so it will back to 0. And this nature is compressive. 66 kilonewton. Free body diagram of member AB. I have sketched axial force diagram. There is no shear force diagram. There is no bending moment diagram. What about for this member BC? BC member थोड़ा सा हमको खेलना पड़ेगा. See, this is the force. 66. मुझे ये फोर्स को क्या करना पड़ेगा? अलोंग एंड परपेंडिकुलर में रिजॉल्व करना पड़ेगा. ये तो ऑलरेडी अलोंग एंड परपेंडिकुलर. दिस 44.04 इज परपेंडिकुलर, दिस 10.56 इज अलोंग. तो मुझे ये यूडीएल का तो पहले से ही काम हो गया है. अभी इसको रिजॉल्व करते हैं. हाउ मच दिस एंगल विल बी? द वर्टिकल वाज 3, द हॉरिजॉन्टल इज 4, सो दिस एंगल मस्ट बी इक्वल टू 36.87. If it is 36.87, this is 90 minus 36.87, so again it will be 36.87. If this is, so this force must be 66 cos of 36.87. This will be 66 sin of 36.87. Cos of 36.87, so it is 66 multiplied by 4 by 5. That is nothing but multiplied by 0.8 actually. So how much this 0.8 will be? I check at the 8, carried 4, 8, 8, check at the 1, so it is 52.8. So this is 52 point, not this, cos, इसका मतलब ये रहेगा. This is 52.8. So this 66 is 50.8. And what about here? It is 66 multiplied by 3 by 5. So that is nothing but actually multiplied by 0, 6, 6, 36 का 6 carried 3, 6, 6, 36, 36, 38, so it is 39.6. So this is 39.6 किलोमीटर. अभी यहाँ पर ये 22 किलोन्यूटन है. दिस वर्टिकली एक्टिंग अप. दिस इज दिस. मुझे इसको भी रिजॉल्व करना पड़ेगा अलोंग एंड परपेंडिकुलर में. देखिए ये एंगल अगर 36.87 इन 90 माइनस दैट एंड दिस इज अगेन 36.87. इफ दिस फोर्स इज 22, तो एक कंपोनेंट यहाँ रहेगा और एक कंपोनेंट यहाँ रहेगा. सो दिस कंपोनेंट विल बी 22 साइन ऑफ 36.87. थोड़ा ज्योमेट्री है. इट इज 22 cos of 36.87. आपको फोर्सेस रिजॉल्व करते आना चाहिए. Sin of 36.87, it is 3 by 5. So that is nothing but actually multiplied by 0.6. So 22 multiplied by 0.6. 6 दूनी 12 के 2, 8 6 दूनी 12 13. So it must be 13.2. So this 22 kilonewton can be replaced by a force of 13.2 along. And what about here? It is 22 multiplied by 4 by 5. 4 by 5 is nothing but 0.8. 8 दूनी 16 का 6 हासिल करेगा. 8 दूनी 16 और 17. So this must be 17.6, which is acting perpendicular to this. This 17.6. Finish. ये जो यूडीएल यहाँ पर एक्ट हो रहा था उसको हमने ऑलरेडी अलोंग एंड परपेंडिकुलर में रिजॉल्व कर दिया है. द रिएक्शंस व्हिच वर एक्टिंग वर्टिकल हियर, those reactions we have resolved along and perpendicular, because when you want to sketch the axial force diagram, you must know the forces which are acting along. When you want to sketch the shear force diagram, you require to have the forces which are acting perpendicular to the member. So we are resolving the forces along and perpendicular. Now for this part, see this is the 22 kilonewton force. Again it is to be resolved along and perpendicular. This is also a 22 kilonewton force. This is to be resolved along and perpendicular. Right? Along and perpendicular. The force which is acting along will call as the axial force. The force which is acting perpendicular, that will call as the shear force. See, what is the angle made by this with the horizontal? It is the same slope. It is 36.87. So this is along and this is perpendicular. So this is 90 minus that. So this force must be, angle must be equal to 36.87. If this is 22, then here the component will be 22 sine of 36.87. And the component here will be 22 cos of 36.87. So sine of 36.87 is nothing but 0.6. So it is 13.2. This cos of 36.87, so it is equal to 0.8. 8 दूनी 16 के 86 का अगर तुम 16 17 17.6. So actually it means that here we are having the force 17.6. Here we are having a force 13.2. Similarly, if you resolve this force, this is here. This angle with the horizontal is 36.87. Corresponding angles or the alternate angles 90 minus that. So this is again 36.87. This is 22. So it is 22 cos of 36.87. What is it? What is right? ये एंगल है हॉरिजॉन्टल से, तो ये एंगल है 36.87. ये और ये करस्पॉन्डिंग 90 माइनस. सो दिस एंगल मस्ट बी 36.87. ये और ये करस्पॉन्डिंग एंगल है 36.87. कौन से बोलते हैं इनको? अल्टरनेट एंगल्स. अल्टरनेट एंगल्स 90 minus, then it is again 36.87. So this will be 22 sine of 36.87. This is 22 cos of 36.87. तो ये वही है 22 sin of 36, 22 sin of 36, 22 cos of 36. This is 22 cos of 36. So it will be same here. This is 17.6. This was acting up, so this is same here, and it is down. It is of 13.2. There is a couple of 88 kilonewton meter also acting. Finish. We have got the free body diagram for the other two members also, where the forces were acting inclined. जहां पर भी कोई डिस्ट्रीब्यूटेड फोर्स आता है इंक्लाइन मेंबर पे, तो काम थोड़ा और बढ़ जाता है. Wherever there is inclined member, हमको फोर्सेस को along and perpendicular रिजॉल्व करना पड़ता है. Right? Now sketch the shear force and bending moment diagram for this part. What is the axial force diagram? Say this is 39.6 compressive. So it is 39.6. And ये क्या हो रहा है? 10.56 अपोजिट डायरेक्शन में चल रहा है. So if you will see here, अगर इसको माइनस करेंगे, देखिए माइनस 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 यहाँ तक पूरा माइनस हो रहा है. तो कितना माइनस होने वाला है? ये 39.6 माइनस 10.56 मल्टीप्लाइड बाय दिस टोटल स्पैन अप टू हियर इज 5. तो 5 के 30 कैरिड 3, 5 में 25, 26 27 28 के 8 कैरिड 2, 500 and 2, 5 एक 5, so it is 52.8. So 39.6 minus 52.8, तो कितना हो जाएगा? ये 2 12 12 में देना हो गया 7 4 17.2, and with minus it will be, and the variation देखिए it is uniformly distributed throughout. ये जो axial force है, so the variation must be linear. तो variation इसका linear ऐसे जाएगा, and here it will be again going back by ये minus 17.2 के 17.6 आ रहा है, 17.6. So it is 17.6, and then it will go back to that. So it is go back to 0. This is compressive, and here it will be tensile. This is axial force diagram. the force which is acting along the axis of the member. यहाँ पर कॉम्प्रेसिव है, ये अपोजिट डायरेक्शन में चल रहा है, सो मैंने माइनस 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 किया अप टू हियर इट इज, सो दैट कम्स टू बी माइनस 17.6 एंड इट इज कितना है, कितना रहेगा ये, हाउ मच दैट विल बी 39.6 माइनस 10.56 इंटू 5 कितना आ रहा है 13.2 आता है क्या, 2 12 में से 9 के तो 3, करेक्ट है 13.2 आना चाहिए क्योंकि यहाँ पर 13.2 एक्सियल फोर्स, सो दिस इज 13.2. इज इट ओके? 52.8 and 39.6, so it is 13.2. 39.6 फिर ये सब्ट्रैक्ट हो रहा है, सो इट इज सब्ट्रैक्टिंग, यहाँ पर हो जाएगा माइनस 13.2, यहाँ पर फिर 13.2 इन द सेम डायरेक्शन, करेक्ट? So it is 13.2 and it will go up. This is the axial force diagram. Is it okay? What is next now? Shear force diagram. आपको ये बताना पड़ेगा कि ये कहां पर जीरो हो रहा है, तो यूज द सिंपल कंसेप्ट ऑफ द सिमेट्री ऑफ ट्राइंगल्स. लेट दिस डिस्टेंस इज x, so it is 39.6, x divided by 39.6 is equal to this remaining is 5 minus x divided by this height is 13.2. So get this position where the axial force is zero, where the axial force is changing its nature. Then you sketch the shear force diagram. It is 52.8. फिर जैसे यहां से यहां तक आ रहा है, it is getting reducing. 14.08 multiplied by 5 कितना होता है, 14.08 multiplied by 5, 8 पंजे 40, 14 पंजे 70, so it is 70.4. तो 52 पॉइंट, तो यहाँ पर ऐसे आ जाएगा ये निगेटिव, because this is force which is acting perpendicular to the member, so that is to be subtracted, and it is UDL, so the variation must be linear, and here it comes to be 17.4. This is plus, this is minus. Why it is 70.4? 52.8 minus 70.4, you will get minus 17.4. फिर ये वापस ऊपर जा रहा है 17.4, so it will become plus. This is the shear force diagram. You need to locate this point where the shear force is zero. How to get it? Again use symmetry of triangle here. Let you call this as x. So now here ये x ये है, यहाँ के लिए जो x रहेगा, it is x divided by 52.8 must be equal to 5 minus x divided by 17.4. You get this position where the shear force is zero. You need to locate the prominent point. You need to locate the point where the shear force is zero. Why do you need to locate the point where the shear force is zero? Wherever the shear force is zero, the bending moment is maximum. That's why we need to locate this point. This is an important point where the shear force is zero, the bending moment is maximum. Now you sketch the bending moment diagram for this. See, there is no moment because of this, there is moment because of this 52.8, there is no moment because of this axial force. And see how the bending moment variation is, it is in between is the UDL. So the bending moment variation will be parabolic. And it will be a maximum below this point. It is 88 down. ऐसे कुछ रहेगा. How? Now you see, I take bending moment at any distance x. How will you get the bending moment at any distance x? It is 52.c. This 52.8 is acting up, so it will produce positive bending moment about this section. So its bending moment at any distance x is equal to 52.8 multiplied by x. Because of this, ये axial force नहीं करेगा कुछ भी. ये axial force will not produce any moment. This 14.08 which is acting perpendicular to the member, that will develop the moment. So minus 14.08 into x by 2. That is the bending moment at any distance x. So it is equal to 52.8 minus 7.04 into x square. अभी मुझे कहां पर बेंडिंग मोमेंट चाहिए? से सपोज आई वांट टू हैव द बेंडिंग मोमेंट जस्ट एट लेफ्ट ऑफ सी, just at left of C. So there I have to put the value of x is equal to 5 meters because the length of that inclined member is 5. So it is 52.8 minus 7.04 multiplied by 5 square is 25. कितना आएगा बोलिए मुझे अभी? हाउ मच रेट विल बी? कितना आता है बेंडिंग मोमेंट? हाउ मच इज द बेंडिंग मोमेंट हियर? Just to the left. कितना आ रहा है? 25 चौक 100 कैरेट 0 0 25 सत्ते 175 और एक 176 176 और डेसिमल 2 के बाद, so that will get subtracted, so it is 176. उसमें से माइनस कितना हो जाएगा? 52.8 मल्टीप्लाइड बाय 5, तो 52 8 5 40 का 0 कैरिड 4 5 दूरी 10 और 4 14 का 4 कैरिड 1 5 5 25 और 26 264 एक के बाद डेसिमल माइनस 176, तो 14 में से 8 गया तो 6 गया, तो इट इज 8, यहाँ बच गया है 5, 15 में से 7 गया तो 8, 1 में से 1 गया 0, so it is 88, so it is positive, so it means that the bending moment here is 88 positive because just at C, तो ये 88 डाउन भी आ जाएगा, so that will come to 0, so this is how the bending moment variation will be. यहाँ पर सबसे मैक्सिमम रहेगा. Now ये जो भी वैल्यू मिलेगा, that value I have to put this in the equation, I will get the maximum bending moment here. Is that okay? Where the shear force is 0, the bending moment is maximum. ये इक्वेशन हमने पहले भी डेवलप किया था क्लास में, if you remember. Wherever the shear force is 0, the bending moment is maximum. हम दूसरा कैसे ये वैल्यू ऑफ x डिटरमाइन कर सकते थे? बेंडिंग मोमेंट का इक्वेशन अवेलेबल है. यूज द कंसेप्ट ऑफ मिनिमा एंड मैक्सिमा. If you use the concept of minima, see here the bending moment varies with the square of x, so it is parabola. Use the concept of minima and maxima, take the derivative of bending moment, so you will have the shear force equate that to 0 and you will get the position where it is 0. Is it okay? हम ऐसे भी सॉल्व कर सकते थे. So get this. Now उसके बाद ये पार्ट है, this is very simple. इसमें क्या रहेगा? Axial force. How much is the axial force? 13.2, 13.2. Compression. This is the axial force diagram. 13.2, 13.20. And this is compression. Axial force diagram. What about the shear force diagram? इसके लिए बोलते हैं कि we have to show the prominent points also. How to sketch the shear force diagram? Shear force diagram के लिए मैं अंदर से देख रहा हूँ. So this is the force which is acting down. So here this is 17.6. फिर यहाँ से यहाँ तक कोई horizontal force नहीं है, vertical perpendicular force नहीं है. Then it is 17.6 up. So this is this, and this is minus. This is shear force diagram. 17.6. What about the bending moment diagram? हम अंदर से देख रहे हैं, यहाँ से ऑब्जर्वर इनसाइड ऑफ द स्ट्रक्चर है. दिस इज द कपल. सी दिस कपल इज ऐसे एक्ट हो रहा है, सो दिस बेंडिंग मोमेंट इज पॉजिटिव बेंडिंग मोमेंट. एट दिस एंड इट इज 88. देखिए, इफ यू वांट टू हैव द बेंडिंग मोमेंट एट एनी डिस्टेंस x, क्या रहेगा? बेंडिंग मोमेंट एट एनी डिस्टेंस x इन दैट केस, दैट विल बी इक्वल टू 88 minus, because of this reaction, see this is how it is acting here, so it will produce the bending moment of opposite nature, so it is minus 17.6 into x. So the bending moment varies linearly, there is no other force acting in between anywhere, so the bending moment variation is linear, so the bending moment variation is linear. And if you will put here the value of x is equal to 5, because when I come to this end, the value of x is equal to 5, the length of this member is 5. So it will be 76 multiplied by 5, and that will come to 0. The bending moment variation is linear, and this is positive. This is the bending moment diagram for that member CD. Is it okay? So when it is an inclined member, हम प्रॉब्लम ऐसे सॉल्व कर सकते हैं. इंक्लाइंड मेंबर्स अगर आते हैं तो प्रॉब्लम में थोड़ा सा कॉम्प्लिकेशन बढ़ जाता है. We have solved sufficient number of problems on the portal frames now, so we can assume that I am concluding this particular topic here and today's lecture also. क्योंकि जो अगला पार्ट है that we will take in the next class, that will take another 2 hours, और हम वो 2 घंटे में एक टॉपिक फिनिश कर लेंगे होपफुली. मैं कभी तो कोई एक आधा एक्स्ट्रा लेक्चर लेता हूँ. अगर डे आवर्स में पॉसिबल नहीं है एंड यू आर ऑल बिजी, सो वी विल टेक वन एक्स्ट्रा लेक्चर इन द इवनिंग आवर्स. लेकिन हमको कंप्लीट करना पड़ेगा. ओके, क्योंकि प्रोफेसर चैननी वाज आल्सो इंटरेस्टेड इन टेकिंग द लेक्चर, सो आई होप दैट ही विल टेक द लेक्चर नाउ. ओके, x is equal to 5. Yes, x is equal to 5 at this end. So put here and that will come to 0. So this is how the bending moment will be. चलिए ठीक है. I am concluding lecture here and this particular topic is over. We will do the remaining part of the syllabus in the next class. चैननी सर लेंगे. थैंक यू. अगर डे आवर में लेक्चर पॉसिबल नहीं है तो हम इवनिंग आवर में लेंगे. आई नीड अनदर 2 hours to complete the part which I was supposed to take. Thank you.